Okay, so we've got this crazy algebra question here. We've got 3 to the x equals 27 to the power of another 3 to the power of 1 plus log of 2 over log of 3 plus 3 to the power of log of 2 over log of 3. And that's all enclosed in the power for 27. So this thing just looks crazy. How are we going to solve this? Well, I've got 3 to the x here. I've got 3 to the power of something here, 3 to the power of something here, and here I've got this 27. Well, there's 3 linked in there somewhere. So 27, I know that is 3 cubed. So I could rewrite that 27 as 3 cubed. So that I could definitely do. But what about this stuff in the top here? What am I going to do with this? This just looks insane. So why don't I set, I can see that these are 1 apart. Why don't I set the larger one to some variable and see if I can solve for it? So 1 plus log 2 log 3. This one here is 1 less. So let's set a variable a. So let a equal 1 plus log 2 over log 3, and let's see if we can do something with that. They're both raised to the 3, so that looks helpful. Right, so if this one here, I could just rewrite that as log 3 over log 3. So let's just do that. So a equals log 3 over log 3 plus log 2 over log 3. So this is all natural logarithm, ln of course. Okay, so now I've got a common denominator, so now I can link these up. So my a is now log 3 plus log 2 over log 3. Okay, now why don't I combine these? So now the laws of logarithms say when you add the logarithms in these indices, I can just multiply the input for the log. So now I've got a equals log of 6 over log 3. So that's my a. Now I've got here 3 to the power of this one. So this one here is 3 to the a. So let's have a look at that. So 3 to the power of a would be the same as 3 to the power of this log 6 over log 3. So let's have a look at that. So that's 3 to the power of log 6 over log 3. Okay, so now what I could do is, why don't I just ignore this 3 and then just multiply both sides by log 3. So just cancel these out. So that's not, we're not going to need to do that. So now, using this a equals log 6 over log 3, multiply both sides by log 3. So now I've got log 3 times a, so I'll bring my a out to the front. That equals log of 6. Okay, well now I could apply the inverse function rule. So the inverse of log is exponential. So let's just do that. And then I can extract my a out of that, hopefully. Right, so e to the a log of 3, that's just going to give me 3. It's not going to give me 3a, it's 3 to the power of a. Now here I've got e to the ln of 6, so 3 to the a, that's just going to give me 6. So now I've eliminated that this here, raised to the power of 3, that's just going to give me 6. So that's what that is there. So I've got here, this is my a. So here I've got, let's rewrite this in terms of a. So I've got 3 to the x equals 27, and then my indice now, 3 to the a. That's what I've done there. A is 1 plus log 2 over log 3. So now I've got 3 to the a, which I know is 6, but I'm just going to write it as 3 to the a for now. And then I add 3. Here I've got a minus 1. Okay. Now 3 to the a minus 1, Well, we could do something with that. If 3 to the a equals 6, let's just write this one here, 3 to the a minus 1. Well, if a minus 1 is in my power there, I could just write that as 3 to the a times 3 to the minus 1, which is the same as 3 to the a over 3. Well, 3 to the a I know is 6, so now I've just got 6 over 3. So now in these powers, I can just write 6 plus 2. So 3 to the x equals 27 to the power of 6 plus 2. So that takes care of that. So now 3 to the x equals 27 to the power of 8. Okay, now I've still not solved for my x. So what can I do here? Well, 27 is the same as 3 cubed. So 3 to the x is the same as 3 cubed to the power of 8, which is the same as 3 to the x equals 3 to the 3 times 8. So now with my powers, as I did here, I can just cancel out my 3's and just say x equals 3 times 8, which is 24. So therefore, this big thing here, this x would now, I just exchange out for 24. And then I've got the correct answer. 3 to the power of 24 is the same as 27 to the power of this crazy indice here. Okay.